I'm Mike Harris. Recently moved to Milwaukee. I've been here about 1 year and 7 months-ish. I've been working in the Milwaukee area for about 7 years though. So most of that time I lived in Northern Illinois, so I had a little bit of a commute. Probably about 1.5 hours one way, maybe an hour, depends on traffic. And so, when you're driving, the first week you're like, okay, I'll listen to NPR and stuff like that. And that gets really tiresome. Similar stories. You're switching states, so you got to switch radio stations and stuff like that. So then I discovered this really cool place that has like audiobooks that are available for free called the library. So I went down to the library and started going through books. And I was like, you know what? I could kind of treat this like a self study course. Go through the great works of literature. So I started picking up stuff like the Iliad, the Odyssey, and then I started picking up some stuff from the Middle Ages, kind of like the Divine Comedy, and things of that nature. I would listen to the books and then listen to some courses on the books and then re-listen to the books because I had a little bit of a commute, so I could afford myself to do these kinds of things, this kind of study. So one of the ones I did listen to a few times was the Divine Comedy. Now, one of the misconceptions about the Divine Comedy is it's all about this. It's all about hell. Well, hell or the Inferno only represents 1/3 of the total work. The other third is Purgatorio, and the final third is Paradise. So the other misconception around the Divine Comedy is that what Dante does is just throw all the people he doesn't like into the Inferno itself. Well, that's not true. More what he does is you see the same family, the same clan people, in all different stages. Instead, what he's more talking about is kind of like strife and political disputes, and people not listening to each other and trying to work together for common causes, and instead taking more of the vicious route. That's where you find all the people in hell. They won't listen to each other. They're sowing strife and discourse. And then what you find is the people in Paradise or in Purgatorio, they're trying to work through their issues, and they're trying to become enlightened and repent. And one of the scenes you find in Purgatorio is a scene where so Dante is traveling with Virgil in Purgatorio, and they're both Italians, and Virgil meets a fellow citizen, from the same city-state. So back then, you did identify more of the city-state than the actual country you belong to, right? So he finds someone from the similar city-state, and they talk about being in a city-state. But then they notice that, Dante can't really, take part in this conversation. So what they do instead is they celebrate their oneness of being Italian. So they talk about being Italians. They find their commonalities, and we kind of have this thing in the programming community where, you're a Rails developer, so I'm not going to talk to you, or you like React, so I'm not going to talk to you. Instead, we should be like, we're all developers. We all develop software. We're solving business problems, and we should try to find our commonalities and the things that are similar amongst each other, and kind of celebrate that and build upon that as a community as a whole. So I could talk about Dante's Divine Comedy a bit, but we're all here to hear about some JavaScript, right? So let's move on. So the Divine Comedy starts with the following statement, very famously. So, midway upon the journey of our life, I found myself within a forest dark, for the straightforward path had been lost. So this line, when I first heard it, kind of spoke to me. Having graduated from grad school, I kind of assumed I could solve anything, And a couple years into my career, I kind of found myself at this turning point where I found out I didn't really know everything. I didn't know how to build a whole system from scratch. I didn't realize all the trade-offs and things of that nature, the things that you deal with in every day. And I became distraught and thought about leaving development. But what I did is I looked back at the people in the past, and I like books from like the 70s, 80s, 90s, and stuff like that. And I said, how did they design? What is actually this thing called software development? And that's what I'm going to share. One of the things I found is kind of like the way that we talk about how data flows through a system. Now, I'm not going to claim to be an expert in this, although when you do a user group talk, you get awarded the title of expert, right? Because you do it for free. At least I'm assuming I'm not going to get paid afterwards. So you get awarded the title of expert, just bestowed upon you. But I'm still learning, but I'll share what I found to be helpful. So we're going to talk about how data flows in a system, and these examples are going to be in SQL. And then we're going to move into the language of data manipulation, and that's all going to be in JavaScript using Lodash. And then we're going to end out in how to talk about data flow in a context, and that's going to all be in Lodash with some Folktale thrown in, and all in beautiful JavaScript. So at the beginning, there's going to be some SQL, so hopefully it doesn't offend anyone and I don't get stabbed afterwards, but we'll see. So let's talk about how data flows in a system. We'll use a very descriptive way of talking about it using SQL. So we're just going to set up a very simple data set to play with. And this is going to be time series stock data. So this is probably the most bare bones table you can possibly have. We have symbols, we have pricing dates, and we have price. That's it. And we just have two symbols and 2 dates. So you can think about these as the price at the end of the day. And these symbols are my favorite because these are the test tickers. So if we're at a party or something like that and you really bug me for some stock tips and you won't leave me alone, I'll just give you these test tickers because you can go Google them and you'll find some values and stuff like that and you'll be like, oh yeah, I got a great tip from this guy, but I didn't actually give you anything. So we have the following data. Let's go ahead and query this data. So we run the following statement. Very simple, very bare bones, very basic. And we're just going to select out the ZV, ZZT from this data set. And we're going to order by the pricing date. Does anyone know offhand the order that these keywords are evaluated in? Anyone? How about Dave?
Yeah, I see the taller people. So first is the from.
Yep.
And then the where.
Yep.
And then the select. And
Yep.
the order by.
Exactly. Thank you. So yes, this is the actual order that a SQL statement is evaluated in. So we see a couple groups here. We have our from, or on, or join, or where. Those are all about extracting and pulling data out, right? Then we have our group by, our with rollup, our having. Those are all about when you aggregate the data. How do you aggregate it and what kinds of things do you do with that aggregation? Next we have our select, and that's all about how you map out the different columns that you're pulling and manipulate the data as you pull it out. And then we have our distinct and our top. Those are about filtering the final result set. And then we have our order by, which is kind of near the bottom. Now, one thing you'll note here, when you use an alias in your select statement, can you use that alias in your where clause? Mark?
I say no, Mike.
Yes. And why is that? Because exactly. So that's like when you first start doing SQL, that's like one of the first things that you come across and you're like, this is the stupidest language ever. This is why it's not available at this point. We see the where clause is all the way up at 4 and the select's all the way down at 8. So it doesn't even know about what the things you're talking about are. That's why it tells you, hey, I don't know what you're talking about in whatever language you're doing. The other thing to note about SQL is this is a descriptive language. You are describing what you want back from the data. You're telling it, this is what I'm looking for. Now, sometimes you might not get anything back. And sometimes when you don't get anything back, you're like, well, did I mess up or something? Well, it might be that there is actually nothing that meets that data. or the criteria you're sending forth is not going to be met by the data set that you have available to you, which is okay. That actually might be success. So an empty result might actually be what success looks like. Ooh. Cool. This died on me. Oh, wait. No, it didn't. Cool. OK. Whatever. So we these were the keywords we had in our statement. This is the way the data would actually flow through. So we grab out, with our from clause, we're looking at 4 records. And then we have our where. We filter down the 2. Now we go ahead and we can manipulate the things that are available to us in the select, map them out. And then when the order by, so we're kind of rearranging things. Note the order by. So with a set, so the data is just the abstract data type of a set. What is the actual order that things come back, or the order that things are in a set? Anyone?
Sets don't have an order.
Exactly. So if you need your results to be in a certain order, use an order by clause, because there is no guaranteed order that a SQL statement will give you back. Now there is a physical order that things are located and organized in, and when you read it back, you might get things back in that way, but it's not guaranteed. So if you really need things to be in a certain order, you're going to have to either put an order by clause or do something in your actual program that's consuming the data to make sure you can guarantee an order. So we have our from, our where, our select, and our order by. Let's go ahead and fold this. So we have a simple select. We have our max pricing date. This will give us back one piece of information, the max pricing date out of this whole data set. So we have our from and our select clause. The way this would look, you grab out the 4 records. All 4 of them presented as select and hand it off to the max. And then the one piece of information comes back. So we have our from and our select. So let's use a group by. So we have our select statement. We're selecting out the symbol. We're finding the max pricing date. And we're going to group by the symbols. So for each one of these symbols, what is the maximum pricing date that we have available to us? We find they're both exactly the same. So we have our from, our group by, and our select statement. If we're going to look at how this data looks, we grab all 4 records, we group by, so now we have 2 groups that we're working with at this point. Both groups are presented to the select clause, and both of those groups are then presented to the max. So the max has 2 different groups that it's working on, and it's going to give back one result for each of those groups. So it moves from our from to our group by, and then out to our select statement. So let's look at a windowing function. This is some of the more advanced SQL stuff. So what we're going to do is we're going to find the max pricing date, but we're going to use a window to do it. And we'll talk a little bit more about windows. Note the distinct on here. We find we have a very similar or the exact same result that we have with our group by in this case. So we have a from, a select, and a distinct in this case. So a window, you can think about a window as, so the way that that SQL processes through, it looks at every single record, and for each one of those records, it opens up a window. Windows have a way that they're partitioned. So in this case, we're partitioning it by the symbol. So for the given record that we're currently looking at, in this case, the CBO one, there are 2 records in that partition because we're partitioning it by the symbol. So we have 2 records in this window. The next part is we're given this window, and the current record we're looking at, what is the maximum pricing date? So when we look at the first window here, for this record, we see that we have available to us this pricing date and this pricing date. So the max one in this case is going to be the 1.4. Next, the engine will go down to the second record here. And it's going to say, given this window, what is the max pricing date? So it's given the exact same window, and it's going to give the exact same result of 1.4. If we didn't put the distinct on here, we'd get back four records. And we'd essentially have duplicates. We'd have CBO with 1.4 and CBO with 1.4. So we use the distinct to chop off those extra records. So it's very common when you have a windowing function to have to use a distinct to filter off the extra records, so to say. So if we look at the data as it's coming through, we go and we extract out 4 records. Then those are presented as select. Now we have 2 windows. And inside each one of these windows, we have groups that are partitioned by the symbol. Each one of those is presented to the max. And we have 4 records at this point with the max dates. These have the same date, and these have the same date, right? So then we go ahead and we chop off all the extra ones. And we're left with our distinct records, in this case, CBO of 1.4 and ZVZZT of 1.4. So it goes from the from up to the select clause. Now, most of the windowing functions have been around for probably about 10 years. And most of the new innovation that's been taking place in like Oracle, SQL Server, MySQL, SQLite, all the different engines has been around windowing functions for the most part. And all these are analytic functions. So this is kind of where all the development's been happening in the SQL space. Windowing functions are part of like standard SQL, so you should be able to use them in whatever you use in your day-to-day work. So let's look at a little bit more complex SQL example, and then we'll move on to some sweet JavaScript. So with this example, what I wanted to show is how you can use a window to look at a record ahead and a record behind, and then use the record ahead and behind to calculate a difference. So what we're gonna get out from that statement is for each symbol, what's its current price? What would be what's the next price? So the day in front ahead of it, or the previous price, so the day behind it. And then what's the change between the previous and the current? So for the first one, we see that there's nothing ahead. This is the very first record in this data set. So that comes back as null. There's no change then. But the next price is the next day's. Likewise, we see down here that we have the previous record, so the one that's before it. The difference between those, the current price and the previous price, and then the next day is null. And likewise with the ZVZZT. So let's look at the lag. So the lag is what allows us to look behind. So as the SQL engine is going across and evaluating the different records, it opens up a window on each one of those. Inside that window, we're partitioned by the symbol. So we have our 2 records in there for that symbol. And then what we have to do is we need to apply some order to it. So the lag knows which one is first, which one's second, which one's third, and so on and so forth. So the window in this case we're going to use is the pricing date, because it would make the most logical sense for this data set. So we organize it by the pricing date. So we have our 1.3 and our 1.4. And what we're doing is we're saying, is there a price before this? So the lag, the first argument or second argument to this lag is the number of records to look back. In this case, 1. You could have it be whatever number makes sense for what you're working on or what you're trying to get out. In this case, it's a very small data set and a very simple example, so we're just asking for the one before. So as the engine is going through, for each record, it's evaluating and opening a window. So for the first one, it has available to it the record it's currently looking at, which is the 1.3 data, and nothing else. There's nothing before that record, right? So of course, it's going to spit out null as the result. Engine comes down to the second record, and this is the 1.4 data. Opens the window. Inside that window is the previous record. And so it can go ahead and return back the pricing date for that, in this case, 1899. It'll do a similar thing with the ZVZZT data. Next, we'll look at the lead. This is the opposite. So the lead's saying what is the one that's going to come up next. So we go ahead and we partition it by the symbol, and we order it by the pricing date. Engine comes through, hits the 1.3 data, opens up the window, and it looks to see what is the one that's going to come next. In this case, it's going to be the 1.4 data with a price of $19.01. So that's outputted. Next, it comes down to the 1.4 data, opens up the window. There's nothing that comes that's next. This is the end of the line. There's no more data in this data set. So it outputs null. And then it'll do likewise for the ZVZZT data. So we have our from and our select clause. Looking at this data as it actually flows through the system, we see we have all 4 records. All 4 of them are presented to the select clause. And then we go ahead and we partition out the data, creating our windows by the pricing, by the symbol, and ordering each one of those windows by the pricing date. Those are all presented to what I'm calling the funcs, or the windowing functions, and then each one of those just has the one record that comes out for it. So we flow from the from all the way up to the select clause. So that was all the SQL examples. Everything else from here on out is in JavaScript. This, we actually can have a common language of talking about data as it flows through a system and how we can manipulate it and use it for our applications. So first, let's look at data flow in an imperative way. We have the following code. Does anyone know offhand really quick what this code is doing? Cool. Yep, so JVR is right. So what we have here is we have a string, and then we have a counter that we're setting at 0. Then we go ahead and we split out the string into substrings, splitting on a space character. Each one of those, we're going to go ahead and apply a regular expression to trim off any white space or apostrophe s's, things of that nature. And then we're going to go ahead and get rid of all the words that have a length that is less than 2. And so we're going to count. So this is basically MapReduce, right? In order to kind of explain imperative code, you kind of got to play computer in your head, right? You kind of got to calculate it, go through a couple loops in your head, and try to figure out what is this actually doing. And that's fine. I mean, this kind of code I wrote for very many years, so I'm not saying anything is really wrong with it. It's just, it doesn't really, I feel it doesn't really reveal your intentions a whole lot. You know, you gotta kind of play computer in your head and calculate things out and do a whole bunch of extra work to try to figure out what's going on. And we can kind of look at the way the data flows. We have the string going into the for each loop, and we're manipulating the string, we're splitting it, we're mutating. We have a GERD, and then we're incrementing things going out of the for each loop, kind of mutating state on the side. So it's kind of a little bit much going on, but you know, it's manageable. Next, we'll look at kind of a nested example of how to do this. So the exact same code, basically, but this is nested. Anyone know where to start reading all this code?
You got to read it from the inside out.
Yep.
So maybe that's
Yep.
the first operation. That it goes out.
Yep. So you start from the inside and you work your way out. So starting from the inside, we go ahead and we're splitting out the string into words, and then we take each one of those words, apply a regular expression, and then that goes out to the filter, and then we go ahead and we get rid of all the words that are of length less than 2, and then that's finally outputted out to the size, and then we go ahead and we count how many things we have left, and that gives us a grand total. It looks very pretty from kind of a diagram point of view. You know, you kind of got this Russian doll thing going on, which looks very pretty, but it's very hard to kind of reason about this code by just looking at it, and it leaves a little bit to be desired. Our last example, we'll look at how to pipe data through. So here we have Lodash's flow. And so we're flowing in, and we're going to go ahead and split the whatever we're given on the space. And then we're going to go ahead and apply our regular expression, and then we're going to filter, and then we're going to count how many things we have left. And we're going to do all that to the string that we're given at the very end. So this is very nice. Has a very nice flow to it. You read it top down, and that's the same way that you apply all the statements. And you only have to, at any one time, really keep one thing in your head, one statement. What is the current statement that I'm typing in, and then what's going to be the input and the output from that statement. So we see we have our string, we split it, we mutate it, then we filter, and then we count how many things we have left. So this is the way that we can talk about data flow manipulation. So we have these basic ideas. We have a map, we have a flat map, we have a filter, a fold, a mutate, a group by, and an order by. These are the names that are given in Lodash. So the map in Lodash is map, the flat map's flat map, the filter's filter, fold's called reduce, mutate's called each, group by is called group by, and order by is called order by. Different languages have different terms for these, but they're always the exact same idea. So first, let's look at map. So with map, every single element that comes in is going to come out. So if you have n things go in, you always have n things come out. So you know exactly what the shape's going to be. You can't throw anything away. You can only apply something to each element as it comes in. So you have n in, n out. So here's a very simple example of map using Lodash. We have an array with 3, 9, 10. And all we're going to do is just multiply each one of those by 10. So we get 30, 90, and 100. We have 3 things come in, 3 things come out. In this case, they're all the same data type, but they don't have to be. If we look at the actual way it's implemented in Lodash, we see that one of the things Lodash does is it'll go ahead and create a brand new result, in this case, an array. And it's going to apply the function you give it against every single element. The function, the lambda that you give it can take 3 different values. The first one being the current thing you're looking at, the second one being the index of the thing you're looking at, and the third one being the array itself. Personally, I've never seen a good use for that third argument. Occasionally, I've used the second one. Most of the time, though, I just use only the first one. And JavaScript being a language that supports many arbitraries, this works perfectly fine. So you can go ahead and just set up a lambda with expecting one value, and this will just apply that the thing it's currently looking at into your lambda expression. Let's look at the second thing in our language of data flow, flat map. So flat map, given n things, will produce at least n things. Most of the time, you're going to get more than n things out, but you're going to at least get n things out. Another name for flat map is select many, and another name is bind. I didn't call it bind here on purpose because in JavaScript that has a totally different connotation, which is not applicable to this. So let's use the second most popular term, flat map. So here's an example. We have we have an array with 2 strings in it. And what we're going to do is we're going to split the string that's given to it. Does anyone know offhand what is the data type that comes out of split? It's an array. So the map part of it, a flat map would say that the thing that's going to come out is going to be a collection or an array. The split here is going to go ahead and provide an array. So if it was just a straight map, what we would have is an array of arrays of strings, right? And that's not what we want. What we want to do is we want to take out at least one layer of that. We want to flatten it. So the flat map, what it does is it'll go ahead and the results of the lambda that explode out into an array in this case, those are each going to be taken out as their individual elements or flattened out. So we have as our output an array of each of the words in this, or each of the strings. So we have 2 strings, an array of 2 strings coming in, and we have, what is it? I think 6 strings that come out in one array. So we kind of have this explosion happen. So as we look at the source code, we see the very first thing that Lodash does is it applies the map. So given the function that you provide it is going to map that across all the values that it's given. So at this point, what we're going to do, what we have with our example is we have an array with 2 arrays with a bunch of strings inside of those arrays. The next thing that Lodash does is it, given those arrays of arrays in this case, with strings in them, it's going to go ahead and flatten each one of those. So it's going to go ahead and apply the splat or the flatten operator in JavaScript, and it's going to push all of those strings that result into a resultant array. So this is the point where it goes ahead and does the actual flattening of the results from the lambda expression, giving us an array of strings. The next thing we'll look at in our language of data flow is the filter. A filter, given n things, is going to give you at least n things, but more likely than not, it's going to give you less than n things. You could think of a filter as like the guard at a club. Some people are on the list, and they're allowed into the club, and other people aren't on the list and aren't allowed into the club. So your filter is given a predicate, which you can think about as your list, and those are saying which elements are going to be allowed into the resulting collection, and which elements aren't going to be allowed. So it's a Boolean expression. So we have a Lodash's filter, and we have a simple collection here with 3, 9, 10, 33, and 100. And what we're going to do with our lambda expression, which is going to return a Boolean of true, false, telling us if the number is even. So each one of these elements is going to go ahead and apply the Boolean lambda against. And if it's true, it's going to find itself in the resulting set. If it's false, it's going to just be left out. So given our collection with 5 elements in it, we get a resulting collection with just 3 elements in it. The data, none of the data has been changed at all just the number of elements in the collection have been changed. Looking at the source code here, we see that we have a while loop running through all the different elements and is applying our predicate in a if condition. So if the result of our lambda expression is true, then it's going to be placed into our result collection. Otherwise, it'll be just left out. And then finally, we return back to the caller the resulting collection. Next, let's look at fold. So fold has two different parts given to it. It has the collection of n elements and a seed value. The result that comes out is just one value. No matter what you give it, you always get one value coming out. A couple things jump out at us. One, the seed and the result are of the same type. So if you have a seed that's an integer, your result's going to have to be an integer. The collection itself does not have to be of the same type, but the result of the lambda expression does. It has to be of the same type as the result. Otherwise, you'll find out, given that JavaScript's a dynamic language, you'll find out at runtime that you've done something wrong, which I've done plenty of times. So don't worry about it. The other thing to note about this is that your collection doesn't, it'll support an empty collection. If you have an empty collection, typically the result would be your seed value, but it doesn't have to be. It's all based on what your lambda actually does. But if you have an empty collection, you're guaranteed to get at least one. You're guaranteed to get one value out of the fold itself. So let's look at a simple example using Lodash's reduce. We'll write a simple sum function. So we have our collection, same collection that we saw before, and then we have our lambda expression. The first argument to the lambda expression is the accumulated or memoized value. I use an M there for memoized. Other people use ACC. You can use whatever you want. I use M because the first time I ever saw this was in Haskell, and in Haskell, by convention, they call it M for memoize, but ACC is just as popular. The second argument to the lambda expression is the current thing you're looking at, the current element in the collection that you are looking at. Most people usually just call that X. In this case, what we're doing is we're just adding the memoized value to the current thing that we're looking at. So given the collection of 3, 9, 10, 33, 100 with the seed value of 0, we get the final result of 155, being the sum of the collection. Looking at this as it flows through the system, we see that we have our collection and our seed value, and our 5 different members of the collection end up as just one value coming out of the fold itself. Looking at the implementation, we see that the accumulator is passed down to the actual func itself. And we see that if you don't, in Lodash, if you don't provide an accumulator, what it'll do is it'll attempt to use your first element as the accumulator. This works fine if you have a collection that has things in it. If you don't, it's a beautiful way of getting a null pointer exception. Me personally, I always give a seed value when I use a fold, but at least in the Lodash implementation, it's optional. I do recommend giving a seed value unless you enjoy having null pointers occasionally happen. We see that it runs a while loop going through each of the values, and it's passing the result of applying the lambda expression as the new accumulator. So it's always building up the final result value in the accumulator that's being passed through to the Lambda expression itself. That accumulated value, or the memoized value, is what gets finally returned back to the caller. So that's why I was saying that the seed, or the thing that initially is the accumulator, has to be this, is going to dictate the type of the resulting value. So your Lambda expression just has to be able to return something of that similar type. Next, we're going to look at mutate, which goes by a lot of different names, do, for each, or a couple of the other terms for it. The mutate operator is most often used in your flows or any kind of the chaining that you do with these higher order functions as kind of like a debugger. It manipulates the environment external to it, so it kind of gives you like a window into what's going on in your actual flow. Given n elements, it's void, so it doesn't actually return anything out. What it'll do is, given if it's implemented right, it'll just return back basically the collection unchanged, more often than not. But yep.
This happened last week.
Yep. It would have been cooler if it was at like a cliffhanger point or something.
Right.
Yeah. Next time. Uh-oh. Let's see. Oh, okay, cool. So any questions at this point? Okay.
So Mike, if you're mutating something, does that like break the flow since it doesn't return anything?
It kind of depends on how it's implemented, but usually your better implementations will just pass out that result. So it doesn't break the flow. It's designed to more give you like a window into the flow itself and manipulate something external. So a lot of times what you can do is you can use like your each or your do, whatever name it's called, or your for each or whatever, to do kind of like a, maybe like a console.log or something like that, to kind of like log out a message, maybe, or you can manipulate something external. So what I would use it for is, say I need to debug or something like that, right? And it is depending on your IDE, it might be really hard to see the Lambda expressions and stuff like that that's currently executing. So what you can do is you can have a variable or something, and then you can use the mutate, your for each, your do, your each, or whatever it is, to mutate that variable external. And then when you're debugging, you can just go watch that variable to see what's going on. It's kind of intended as like a way of channeling something out and not breaking the flow that you're currently in. Does that make sense? Cool. Any other questions? Okay. So here's an example where we're going to mutate something external to the actual function itself. So we'll set up our variable r, which is going to be an array. And what we're going to do is we're going to go over each one of these values using the mutator operator, or one of the mutator operators in Lodash called each. And what we're going to do is we're just going to push the values that are divisible by 3 onto that external value of r. So given the 3, 9, 10, 33, and 100, we would get the final, our R would eventually contain the values 3, 9, and 33. And in this case, nothing would be outputted from the each. So we get 5 things coming in, and we mutate 3 things out external in this case. Next, we'll look at the group by. Given n things in, we're going to get at least n things out. Hopefully, if our grouping actually did some type of group, we'd get less than n, but n's like the ceiling that we would get. So given an array, we can group the elements by if they're even or not. So in this case, if they're divisible by 2, they would be outputted in the true value in the resulting object. So the 10 and 100 go in the true, and the 3, 9, and 33 go in the false side. So given 5 things in, we get 2 groups that come out in our object, a resultant object. Last, we'll look at the order by. So the order by, given n things in, we get n things out. So the only thing that the order by changes is the actual order of the elements in the collection. Nothing else is mutated on the elements themselves. So given an array with 33, 9, 100, 3, and 10, and no lambda expression for how to sort them, it'll just use the default sort and give us back 3, 9, 10, 33, 100. Nothing really shocking, probably. The implementation is rather shocking for Lodash, which is why I didn't leave it. Given 5 things in, we get 5 things out, and I did my best of trying to show that they're reorganized, which is kind of hard, but yeah. So we've talked about kind of a language of describing how data is flows and can be manipulated in that flow. Let's talk about data in context. Now, context is very important. Data, in my opinion, without context is kind of worthless. You kind of need to know what the context of the actual bits are to even make sense of what the data is telling you. You know, if you're just given a bunch of random data and you have no context at all about what it is, I challenge you to try to figure out what it actually means. I mean, you might be able to say something about it, maybe, but you're probably going to be missing a whole lot of things without knowing the context of what the data is related to. Now, context is very important. So we'll use a quote from Dante, one of my favorite quotes. So this is talking about Dante being an exile. So, you shall leave everything you love most dearly. This is the first arrow that the bow of the exile shoots first. You are to know the bitter taste of other's bread, how salty it is, and know how hard a path it is for one who goes descending and ascending other stairs. So the whole context of the Divine Inferno, Dante is writing this as an exile from Florence. So if you think politics here are bad, you should have seen Florentine politics at Dante's time. Assassinations in the streets, just very brutal politics. Dante was born into an aristocrat family that there were 2 major powers. The family he's born into, they become the party in power, which is great. But then that party itself has 2 factions, and Dante finds himself on the wrong faction and is exiled from Florence. He never returns. He dies in exile. His body is eventually supposedly brought back to Florence like 100 years later. At least the Florentines claim that, and the city that the other city claims that they have his body, so you know it's a mystery. But Dante is never allowed back in Florence. He's in exile, and that is the context that the Divine Comedy is written, and that kind of characterizes what he's talking about when he's talking about the strife that the people in hell have brought upon themselves and upon their fellow men and women. The line about the salty bread is talking about Florentine bread has no salt in it. So any other bread that Dante's going to taste, because he's in exile, that bread is going to taste salty to him. So I think about that when I'm having like a bread that is rather salty. And the stairs that Dante is going to travel through, These aren't the stairways of his his family's home or anything like that. He's an exile. He's at someone else's place. He has to travel other streets and stuff of that nature. So that's kind of the way that the whole Divine Comedy is characterized. That's the context it's written in. And I think that's very important to kind of understand it. And likewise with our data, our data lives in a context. When we're manipulating the data, there's a context and a reason for that manipulation and that flow. So if we're going to talk about context, context can be broken up into 3 different parts. We're going to lift things into a context, we're going to do stuff in a context, and then we're going to remove things out of the context. That's kind of the way we can think about data as it moves through a context. So you have to bring it in and do something and then bring it out. Yes?
How does this differ from a filter?
So a filter could be a step in a context, or you could think about the filter itself as the whole context, right? So you bring things into the filter does whatever predicate it's going to do, and then they remove them out of the filter, right? So you could think about the filter as like a very small kind of context, right? But we can use that same idea that we understand with the filter, and we can apply that to larger contexts, like how you manipulate data as it flows through. Like maybe you do, you're using a reactive JS, right? And so you make a call out to a web service, and as those results are coming back from that web service, you can go ahead and you can map them, you can filter them, you can fold them, and then finally, at the very end, you do your subscribe, right? And then that tells you, that tells you once you apply all these things in this context, what to do, how to remove it out of that context, right? So thinking about it as a filter, you can use that same intuition to kind of understand the same idea in a larger context. That kind of makes sense?
So a filter maybe is one functor, and context is a set of complex functors.
Yes. Yeah. It all depends on what kind of context you've established, and we'll look at that in a couple different examples. Excellent question. So let's look at the most basic context there is, the identity context. The identity context does nothing, so it's the most basic one to look at. So since JavaScript doesn't have a built-in identity context, I just made one. So we just have a simple class we call identity, and it has one function in it, of. And this is our lift. Traditionally, the lift is called of or unit, depending on the language. Most people seem to prefer of lately. In this case, we're going to use this really cool thing that's built into JavaScript called an array, which has all these other cool kind of ways of manipulating the data that we've been looking at. So this gives us our maps, our filters, and all these other things, kind of for free in this case. The shift operator is going to be our way of removing things from the context. So you could think about that as your folder reduce. Given this very simple example, we're going to lift in the string 33. We're going to map it against a function that takes takes strings and returns back integers, the to-integer. And then we're going to just increment the values. So we're going to call the add with just the value of 1. And then we're going to remove it from the context. So in this case, the integer 34 comes out. So let's look at this as it flows in. So we lift in the 33 into the identity context, then we apply our 2 functions against it, and then we remove it out, giving us the value 34 on the way out. So the context itself doesn't do anything, but it allows us to kind of apply these lambda expressions in these in the language of data manipulation that we've been talking about against the values, and then give us and then allowing us to remove things from that context. So we have our lift, We have the context where we're applying the data manipulation against it, and then we remove the values out. So let's look at a little bit more in-depth example. So we lift in the string that we've been working on, the first line of the Divine Comedy, and we go ahead and we map them. We split out the values. Then we reduce with the concat. The map and reduce combo is the poor man's flat map because ES6 doesn't have a flat map. Then we go ahead and we apply our regular expression. Then we filter. And then we reduce, removing, giving us the final value of 6 and removing it from the context itself. So a string comes in and the value and the number of words greater than 2 comes out. So we have the string that we lift in, we apply our data manipulation, and then we remove the value out. Let's look at a string context, something very familiar to every developer. So we have a string, the same string we've been looking at all night. We go ahead and we split out, and then we can map the results. So we have an array of strings at this point that are words. We apply our regular expression against each of those words. We filter it down to just the ones that are greater than 2. And then we count how many there are. And so in this case, the reduce is removing the values from the context, the string context, giving us the final value of 6. So we see that we lift in the string, we manipulate it with our data manipulation language that we've been talking about, and then we finally remove the value from the context that we've placed it in. Now we'll go to a context that's probably not as familiar to everyone, the maybe context. The maybe context you can think about as an if. So given this lambda expression here, what we're going to do is we're going to see if the value given to it is truthy. If the value is truthy, we're going to go ahead and trim it and then find the length. So we're kind of presupposing it's a string, which we'll see is a little dangerous, but that's fine for this example. If it's not truthy, then we'll just return back the value of 0. So we could kind of understand that we're lifting the value into the conditional or the if context with the if statement, and then we manipulate it and finally return out a resulting value. So our return is kind of our remove. We can bring in Folktale, which has a maybe. The maybe has a static function or static method called from nullable. This allows us to treat a value as a possible null. In some languages it's called maybe, other languages it's called option. These things are becoming more popular. If we do have something that we can work with, we're going to go ahead and apply a map against it. And then finally, we're going to remove the value out. There are two possibilities from a maybe. There's a nothing and there's a just. So the nothing means that the condition that the maybe was set up around, in this case, nullability, if it was null or not, the nothing would represent a null. So if we had a null value come in here, we would not want to do a trim on it because that would blow up. So instead, what would happen is when the value is brought into the maybe context, it would be known internally as a nothing, and the implementation of a map on a nothing doesn't do anything to it. It doesn't actually apply the lambda expression, so it won't have the possibility of a null pointer exception in this case. If the other possibility is we actually have a value there, and that's the just, which is sometimes called the sum. And the just means we were able to actually apply everything to it. You know, it didn't blow up on us. It didn't not meet the condition. So at the very bottom here in the kata, we can either have a nothing or a just, and we just have to say what to do with them. Now, this should look kind of familiar if you've worked with promises or observables in any way. With a promise, you have to deal with the error condition, and you have to deal with the happy path condition. Same thing with observables, right? With observables, you have the next, the error, and the catch, or the complete. And so this is the exact kind of idea. You know, we have two different possibilities here that we have to handle. We have the nothing case, or the null, and we have the just, or we have a value to manipulate case. So we lift the value into the maybe context, checking to see if it's nullable. Then we could apply a map, and then finally we can go ahead and remove it from the context, folding it and counting the value. So in the case of a null, we get 0. In the case of something, we get the actual number out. So let's look at a little bit more complex example with the maybe context. Oh, this is the same example. Oh, okay, never mind. Oh, whatever. So what we're seeing here is that this will actually handle the null. So we can call it with the string that we've been working with all night, and we get the value 6 out. Or we can call it with the null, and we get the value 0 out instead of a null pointer. So given the maybe context, we can go ahead and use the same data manipulation language that we've been applying all night to split out the string, map, applying our regular expression, filter out the resulting values, and then just deal with the two different cases that we could have. We could have the one where we had a null initially, so that should return back 0 and not have a null pointer exception. Or we have a collection of words, and we can go ahead and find how many words are in that resulting collection and get us back the number of words that was in the original string. So we lift in our string, we manipulate it through, and then we finally fold and return back the resulting count. Last example of the night, we'll look at the list context, which should look super familiar. This is what we've been talking about all night. So the flow itself is a context. It's a context that manipulates a list. So we lift things in to the actual flow, and then we go ahead and apply all the different manipulations against that collection. Finally, we're removing it out with the size operator at the very end, or whatever the last operation is, giving us back the number of strings or number of words in the string that we give it. So we lift things into the flow context, in this case the string, apply our data manipulation, and then fold out the resulting value. So these ideas of data are very powerful. We see that we can talk about how data flows through a system. We can have a common language of describing how we actually manipulate data, which is very useful. This allows a Haskell programmer to talk with a Scala programmer, to talk with a JavaScript programmer, to talk with a Java programmer, to talk with a .NET programmer, and so on and so forth. This allows all different kinds of communities to come together and discuss how to solve common problems that we all face, in our day-to-day lives as developers. We see that we can use this language of talking about how to solve problems in a context we saw that we can apply this language of manipulation in a list context, in a maybe context, in a string context. And it's always the same idea, just inside. It might have a slightly different meaning or tint in the context itself, but it's always the same way of talking about the way that data flows through the system. So I invite you to go out and explore other communities and talk with other people and find out how they solve their problems and see what ideas you can borrow and bring into your own everyday work as a developer. And I thank you. So if you want, this is QR code. This will bring you to this GitHub that has the slides, the code examples. Feel free to reach out to me on Twitter, and then there's my blog. I always think talks like this are like a beginning, so I've given possible next steps. You can attend Strange Loop. You can watch this video series, which is excellent. You can read this short, very entertaining and pictorial blog post on functors, applicatives, and monads. Hint, we were talking about monads at the very end of the talk. Spoiler, they're not that scary. There's a book on functional programming I highly recommend that uses JavaScript. And then finally, the last link is to a free book that taught me a ton about functional JavaScript in the original version that talked about ES5, and he's updated it for ES6. And then I linked to the source code. Yes, Lodash really does not have semicolons at the end. And here's the repo to prove it, and then the bibliography.